Hey everyone, it's Miss B, and I am going to do a video today on our Unit 7, Lesson 1 through 10 review. So, this first question, I'm going to try to make it fast today too. So, this first question is actually this entire thing. Like, this is one big question. It looks like it's 6 different ones, but let's read our instructions. We want to select everything that has no solution and then explain or show our reasoning. So, we want ones that have no solution. So the only ones I have to actually pick out here are ones that just don't work. That means we're going to look at when something has no solution. So to start with, taking a square root is definitely something that can give us no solution. And that actually happens here when we take the square root of a negative. So I would say that A is one of our answers because we can't take the square root of a negative number. Cannot square root a negative number. And that would give us no solution. Now, if I'm taking the square root of a positive number, that's going to give us 2 solutions. For B over here, if we look at this one, you would add 5 to both sides. And this is actually going to be x plus 4 squared equal to 1. So we would be taking the square root of a positive there. So it's not going to end up as B. On question C, the work I would do here is first divide both sides by -3 in order to get x squared by itself, just the thing that's being squared. So that's going to leave me with x squared, and then 12 divided by -3 is -4. My next step is to take the square root. So since I can't take the square root of a negative number, I'm going to say it's this one because we can't square root a negative number. So on the top row, the first one and the last one, we would end up taking the square root of a negative, and that's why those ones have no solution. It did ask us to explain or show, so I'm making sure that I do both. Now we're going to look at this next row. Only one of these is actually quadratic, and it's this one here. The other 2 are linear. So this to me looks like a 2-step equation. And if we actually take a moment to solve it, you would subtract 5 from both sides and get -2x is 2. When you divide by -2, you'd end up with x as -1. So D is not one of the answers because that has a solution. Let's look into E. On this one, I want to get this squared part by itself. So I would start by subtracting 15 from both sides to remove this part here. So -15 and -15 from both sides of my equal sign. Then we have x minus 1 squared is equal to 0. I don't want you to think that this one has no solution. 0 is a number, and it counts as a solution. So if we were to then take the square root here, we do end up with x minus 1, but then it's equal to positive or negative 0. This is when we only have one solution. So this is one solution, not 2 solutions or none. 0 works as an answer because adding or subtracting it doesn't work. This just becomes x equals 1. Now, you don't actually have to show all of the work solving these. All you have to do is be able to identify which ones actually give you no solution. For question F right here, if you have a keen enough eye for linear functions, you might be able to tell that this one here has no solution. And that is because if we subtract 3x from both sides, then we end up with -1 is equal to 6. And that is not true. So this one is also one of our answers. So for this question, it would be A, C, and F, because the variables cancel out. So let's write this a little closer up. Variables, it would say they cancel out or they all drop out, but variables cancel out and they disappear completely. So that's what causes that. That's question 1. We're going to move on to question 2. We are going to use this graph to select one statement that is true and then explain our choice. So let's look first just at our function here. This looks like it's vertex form. Our equation there is graphed. Let's read through our answer choices or options. First one says it has no solution. The second one says it has one solution, and that's 8. The third one says we have 2 solutions, which are 2 and 4. And then the fourth one says it has infinitely many solutions. So we have another question here about how many solutions this has. And I understand where you can get some of these from. The correct answer here is C. The equation has 2 solutions, which are 2 and 4. And those come from the x-intercepts right here. So that's going to be my explanation. The solutions are the x-intercepts. That is what we consider the solution to a quadratic. We also may refer to them as zeros, but solutions, zeros, those are our solutions. That brings us down to question number 3. And I do kind of like this one. It's a little tricky, but it works out pretty nicely. So what we're given to start with is an incomplete factored version that's then equal to an incomplete standard form. Now, I know we're going to have a couple different pieces here that multiply together. We're going to have the x multiplied with the x, which we don't know yet, and that's going to give us this first term. We're going to end up with our 3 multiplied with this one, and then our x multiplied with -7, those should all combine to give us this here. But 3 with -7, those ones actually will give us this number right here. And since I have both 3 and the -7, we can fill in this answer. This should be 21. So we would start off with 3 times -7 being that 21. So that's the first thing I was able to fill in. Now from there, I know this has to multiply to make 21. Now I'm going to look at this -x. It has to add up to a -1. So I'm actually just going to write a 1 right in there. And we can do some of that guess and check stuff. Because here, we know this will make -7x. We need to figure out what can we put in here so that these numbers combined make our -1. Well, we have -7. We would need to add 6. So somehow this needs to become a plus 6x in order to work. And in order to make plus 6, we have to multiply these two. So that means this box right here should be 2x. So for this second part, we were using the idea that -7x plus 6x equals the -1x, and that this was created by 3 times 2x. Now the very last part is what is created when we multiply x those both add in over here, and we get 2x squared. I should write all of this in red, since 2x squared. So the full thing, you could fill those boxes in, but your full thing here should be x plus 3 times 2x minus 7 is equal to 2x squared minus 1x minus 21. And that is your full version. So we're going to move on to the back now. And let's take a look here at number 4. Again, more of stating zeros and looking at number of zeros or solutions. So zeros, this is another way of saying solutions, or we also call them x-intercepts. When they're asking you for any of those things for a quadratic, they mean the same thing. So first, looking here at A, we have g of x is equal to x squared plus 14x plus 49. So we need to factor this and see how many factors we have. We are going to end up with x plus 7 times x plus 7. This is g of x. Now, we know that because when we're trying to create our x pattern here, we need something that multiplies to 49 but adds to 14. And out of the factors of 49, the only ones that work are 7 and 7. So the number of zeros for this is 1. And you might be thinking, oh, Miss B, you just put 2 factors there. And the explanation for this is that there is only one unique factor. Because x plus 7 is repeated, we don't get to count it twice. Only one unique factor. Or instead of unique, you can say only one different factor, something like that. You can say the one answer is repeated. There's a number of ways you can say that one. So now let's look at B. This one here is asking us, well, just about this one here. On the first one, we had to actually factor that one. This one, we don't have to factor. It's already in factored form for us. They're not asking us to solve, so all we have to do is identify how many solutions there are. Well, how many solutions are there here? That is dependent on the number of unique factors. And for us, that means 2, because there are 2, and I'll write different on this one, 2 different, and I can say unique factors. So if you really wanted to look at your answers, or to know what your answers are, first we would plug in positive 1/2 here, and that would create 1/2 in this spot. And then this answer would end up being a positive 2. So they are actually different from each other. But since we have 2 different or unique factors, we would get 2 different answers. All right, for question 5, this is factoring. So I'm going to go through this a little bit quickly, but hopefully you'll understand the way I'm factoring this. This first one here for A, this one factors as a difference of 2 squares. And if it helps, you can always use x instead of the variable and then switch it back out. So if having m squared in there throws you off, you can use x squared while you're working on it, and then make sure that you write your answer with m. So this should be m minus 9 and m plus 9. So what will happen there is that 9 times negative 9 makes negative 81, but they add together to make 0 for the middle. B is also similar. These are both perfect squares. You can actually take the square root of 169 and I believe that square root is 13. I'm going to double check myself on that. Yes, it is 13. The square root of, or the next perfect square after that is 196. So with the two numbers at the end swapped, and so I always forget which one is actually 13. So since a difference of two squares factors using the squared number at the beginning, all we're doing is taking the square root of 169, and that gives us 13. So that is the number in the left-hand position of each factor set. And then when we square root 9x squared, this becomes 3x and 3x. Then we just have to make sure we have 1 plus and 1 minus. C looks pretty similar to A and B. However, this one is not factorable because A and B only work because they have a plus and a minus, and that makes the second term negative. Since this one has two positive terms, it is not factorable or prime. That brings us then down to D, where we are looking for x squared plus 3x minus 18. So let's write out our factors of 18. That would be 1 and 18, 2 and 9, 3 and 6. And I believe that is it. So, yeah, because 4 does not go into 18, and neither does 5, and that brings us back around to 6. So this one is also going to be not factorable. Because there is no way for me to make 3. Oh, no, I totally lied on this one. I'm so sorry. In my head, I knew that there was a combination not factorable. Spellman, what are you talking about? These ones right here. Jeez. 3 and 6. So this one is definitely factorable. Hopefully you caught me on that one. I'm glad I caught me on that one. Since the 3 in the middle is positive, we want an x plus 6. We're going to make our bigger number positive, and then x minus 3. Make the smaller number negative. That'll leave us with a positive in the middle. Now it is our next one, I believe, that's not factorable. 18, 15, you know, factors are kind of the same, I guess. 1 and 15, and then 2 does not go in, but 3 does, and it's 3 and 5. So this one is not factorable because there's no combination that adds up to 5. Or you could write prime. Now for F, the very last one here, we're looking for something that multiplies to make 81 and adds up to negative 18. And there most definitely is. You could write out your whole factor chart for 81, but you will find that this should be t minus 9 and t minus 9. That is because negative 9 and negative 9 will combine to make negative 18, but then multiply to make positive 81. So for 81, this would be 1 and 81. 2 doesn't go in. 81 divided by 3, that gives us, 3 and 27. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. I think it's just our powers of 3, so then we would have 9 times 9 on that one. And that's our combination. So that is question 5. Sorry about that little goof up on part D there. We're almost done. Question 6 here says find the perimeter of the rectangle if the area is this expression. So it says find the length and area. That's a typo. Find the length and width. They really want you to just figure out, hey, what could the length and width be on this? Because length and width are what you multiply to make area. So they're saying we need to factor this. So we're going to say factor. We'll do this one in pink, I guess. So we are looking for things that multiply to make 7 and add up to make 8. Well, the great news is that the only things that multiply to make 7 are 7 and 1 because it's prime. So x plus 7 and x plus 1 will equal the x squared plus 8x plus 7. Now they want the perimeter. That is more of the difficult part here. So I'm going to move this piece a little bit because each part here is going to be one of those numbers. So I'm going to say that the top, because we tend to say that the length or the longer side, I'm going to say that one's x plus 7, which also means that the bottom here is going to be x plus 7. And then I will say that x plus 1 is the length of the sides, and x plus 1. Now the perimeter is adding all the way around. So for perimeter, we would add each of these. So we're going to have x plus x plus x plus x. Those are all of our like terms there. That's 4x's, 4x. And then we would have 7 plus 1 plus 1, or 16. So the perimeter, or the answer we're really looking for on this one, is 4x plus 16. That is now going to bring us down to question 7, where it says solve and show your work. So we'll do this one in, I don't know, what color have we not really used here? Let's do this in blue. So solve and show your work. Since this one has an equal sign, sometimes it can hide there and look like a minus. We're going to actually have to set this equal to 0 first. So I'm going to subtract 21 from both sides. Now, what happens here is that 21 doesn't combine with anything. We're just moving it. So it doesn't get to combine with anything here. Now, we want to be able to factor this. So we're looking for factors of 21. And since I'm showing all of my work, I'm going to show that I'm writing those out. 1 times 21, 3 times 7, and that's it. We want numbers that will create -4. So we're going to use 3 and 7, and the 7 will be negative, and the 3 will be positive. And now we are not done, because anytime we have an equal sign, we need to solve for x and give a number where we have x equals. So we're going to say x plus 3 equals 0, and x minus 7 equals 0. Because we have, oops, that's not what I wanted. I wanted this, because we have this piece here multiplied with this one creating 0. The only way to do that is if one of those is actually 0, but we don't know which one. So we're saying, okay, well, what if the x plus 3 was 0? Or what if the x plus 7 was 0? We're finding out which cases would actually work. So these are each one step. You would end up with x equal to -3, or x equal to a +7, and that would be the answer for this one. Now for B, B here does not have an equal sign, so we are actually just going to multiply this one out. You can do this in several different ways, but we're just going to multiply. You can show the box method. You can use the distribute method with the arrows. You can use the split and distribute method. All of those are valid. I'm going to show the box method for this one. Sometimes if they say like, show a diagram, this is also what they mean by the diagram. Just scoot this to make sure I have enough space. And we're almost done. So 3x and minus 5. I could also put 3x and minus 5 on the left-hand side going down. It doesn't matter which direction you put which ones, as long as you're multiplying them, you'll be fine. So 3x times x will give us 3x squared. We're multiplying to fill this box with whatever number is above it and whatever number is on the side. So for this box, negative 5 times x. So negative 5x, that makes the bottom left box 9 times 3, 27x. And then 9 times 5, but 5 is negative. That's going to give us negative 45. So here we would then, I meant to scoot it over, not zoom it out. We can write this whole thing out and simplify. So 3x squared minus 5x plus 27x minus 45. We're going to combine the negative 5 and the positive 27. So we would have 3x squared plus 22x minus 45. And this is the answer that we were looking for. And that is the entire assignment. Hopefully some of my explanations there helped and made some sense. I know you have a test on this tomorrow, so hopefully this helps and you don't really have to ask any questions in class. Good luck.